Hi, welcome to the Compressed Air Service Academy in Malaysia. This is where we do our physical and theoretical training on Atlas Copco equipment. What you can see behind me is the some examples of a bit of medical gas here. We have an AGS right there. We have an alarm right there. And behind here is we have a VSD compressor GA and a ZT compressor, which will be mostly used by the CTS Academy under industrial. So let's pan the camera on this side. I'll show you the medical side area. What we have here is the Lifeline automatic manifold from UK, the emergency reserve manifold 0201 from UK. So this comes as a standard with a 2x1. And then there are samples of gem shell outlets here. This is from the UK standard. Some samples from the America, the NFPA standard gas outlets here. This is the instrument air control panel, mostly used by the Americans for instrument air or surgical air. So this will be located inside the operating theater. A sample of an HTM UK AGS switch, US zone valve box with the total infinity, which is our most advanced alarm in BeaconMedaes. A sample of a MediZone panel, complete with zone service units of oxygen, air, and vac. And this is our the MediPoint 26 non-digital. This is the analog one. But what we sell today are the digital version, which we don't have it in here. Okay, going over for the Lifeline automatic manifold. This is no stranger to you. I'll show you the insides. So it's a very simple unlocking mechanism here and here. And on the inside panel, there's a quick guide on wiring diagrams and the components of the equipment. Going in, you can see if you focus in here, this is this manifold is special to BeaconMedaes because we use two-stage regulation. The first stage regulator takes up to 150 bar down to 15 bar of pressure. Going up to the second stage regulator, delivery pressure depends on what kind of gas that you are delivering, either a 4 bar, a 7 bar, or 11 bar. A solenoid valve to open and close. So this solenoid valve, if there's no electrical power, it will open. With electrical power, it will be closed. Manual ball valve for maintenance. These are the sensors for the line pressure, which goes into this panel here. So this panel here, as you can see, is a digital signal coming from pressure sensors or pressure transducers. 4.5 bar means it's reading a pressure from here. If there's no electrical power, this manifold can still keep on running, where two of the sides are open automatically by switching off the solenoid. So what they can do is they can still control the delivery pressure from each of the banks from here with the analog gauges that can be used as a redundant system. So the most important thing about this Lifeline manifold is we use non-halogenated components to make sure that there's no fire occur during the with high compression gases. Each of the manifold comes with the built-in terminal unit test point. So this is an oxygen terminal unit, and for a 4 bar, 7 bar, 11 bar, the difference, the most of the equipments are the same except for the terminal unit, and also the safety relief valve up here is also different for different 4 bar or 7 bar manifold. Okay, so if you come closer, if you could see the screen, so what you have here, you have an indication of pressure remaining on the right bank, pressure remaining on the left bank. So as you can see here, the manifold is running on the right side because that's the availability of the gas. But on the left side, it's empty. So right now, there's an alarm says standby warning or standby running to alert the engineers to fill up the left side of the bank. And there's a safety feature on Lifeline manifold where you can't actually switch from this bank to this bank when this is empty. If you see, if I click this one, I'm trying to switch to the left, it can't. It's a selection failed. Cylinder bank is empty. So this is a safety feature to make sure that the continuous gas of supply running to patients. On the right and on the left of the screen, of course, there's a simple LED light that says running or empty, running or empty. So you can see the difference there, empty, running. So in case if the screen doesn't work for whatever reason, you still have those LED lights as a redundancy system. And at the bottom here are also the alarm signals for standby running, standby low, and reserve low according to the HTM standards of alarms. On the reserve low, if you don't have any ERM connected to this panel here, this is not being used. Okay, so because this is being wired manually, if I open this box, to RMA, as you can see there, T3 and T4 label RMA. Right now I'm shorting these two terminals because I don't have any ERM running through this box. Okay, and another thing is on this one here, there's P13 and P14. So P13 and P14, these are jumpers here. What you can do here is that you can take a test pen to shorten P13 or P14. So one of them is for, if I close this, is to reset the service line. The other one is to reset the manifold itself. So that's a quick run through of the manifold system. Oh, by the way, one last thing is the most important people usually ask is about alarm connections. So the alarm connections, there are two ways of doing it. If you're connecting to the MediPoint alarm of BeaconMedaes MediPoint alarms, we use line contact monitoring alarms. So alarm panel. So you would use the alarm outputs here, A10 to A14, or you can use it here. If you're not using the BeaconMedaes MediPoint alarms, you can connect using this BMS output. So this BMS outputs uses two wires for one signal. Two wires for one signal. From B1 to A15, so you can refer this to the manual to make sure to ensure which one goes where for your change cylinder, standby running, standby low, and reserve low. Okay, so that's about it. A quick run through of the Lifeline manifold by BeaconMedaes. Thank you.